Hey everyone, Ryan with Geek here. By the way, the channel just passed 1,100 subscribers, so welcome to all the new subscribers. And I just want to thank you for the growth and for following along with our fun here. So what we're looking at in this video is progress on the DC40 build. And tonight I sat down for a couple hours and finished the audio amplifier. Now I haven't tested anything yet, haven't powered it up, but I do have a power adapter, power plug here. I can't. My words are not working here. I do have a power plug, and of course I've got this guy to go with it later on. Haven't decided how I'm going to power this yet, but I have some ideas. I have mentioned using an RC battery pack, and I still am thinking about doing that. But I think to test it, I'm probably just going to get a AA pack, or I've got a 4 amp 12 volt power supply here, and I think I might just use that. It's missing a piece though. I have to get so I can use it. So I'll probably use that just for testing, and then when I actually build this, I'm going to 3D print a case for it, and I'll probably build a AA holder into the case when I 3D print that. That's probably what I'm going to end up doing now that I'm actually thinking about it out loud. So anyway, what we've got here, just to recap, we've got the BNC connector for the antenna in, this is a 40 meter bandpass filter, the double balanced diode ring mixer. So here's the diode ring mixer itself, and it's double balanced because you have a 50 to 200 ohm transformer here and a 200 ohm to 50 transformer here. We want these diodes running at 200 ohms. That increases the voltage, gets them to their voltage operating range. That is my understanding. If you know better than me, please comment below. So the VFO gets fed into here, and it gets fed into, I think it's right here. One of these is in, one of these is out. I'll have to look at the schematic later, but at any rate, one of these is going to go over to the input, which is right here. And then we've got the audio amplifier here going to an LM386 board that I purchased on Amazon. Got like 5 or 6 of them for 10 or 11 bucks. They're just, a couple bucks a piece. And then the output to the speaker is this guy right here. So we have ground and out. So you just hook up a speaker right here. Done. And of course power goes in, and I've got power going in here, VCC in. This is signal in, so signal comes from this capacitor here. And that's pretty much it. I was going to use this kind of layout that I did here, but I didn't. I just kind of winged it, and it was fine. The only spot I wish I'd done a little bit differently, and it's kind of hard to see, is right in one of these junctions right in here. There are 4 devices that connect on one pad. That's actually quite a lot. If I were to do it again, I would have used a little forethought and probably just connected 2 pads and give myself extra room. But really, it's fine. And the main thing here with any of these is warming up the pad first and soldering it, tinning the pad, and then putting the device down on the pad. And for every device here at the bottom, you can see it really well on this guy right here. You can see how I have actually bent a little L into each thing, and that helps them stick. So like this one here, oops, let's see, which one was I touching here? This one here. Give me a big fat finger in the way. It will not lift off the pad. I can sit here and tug on it. Where was it? I think it was this guy, right? This capacitor, I think. Yeah, it was that capacitor. And also this resistor. If I can get that, yeah. And it's not going anywhere. So you always want to give them a tug test, because you're basically using through-hole components as surface mount. So by giving them that little L shape at the bottom, it gives them more surface area to connect. And that works really, really well. So what's the next step? Well, the next step is to take this VFO over here and reprogram it. Or I have some other VFO options. So what would you guys rather see? Would you rather see me take this custom VFO board that I built for my BitX40 rebuild, which I have yet to complete, and repurpose it? Would you rather see me build a kit? It's a SI53518 VFO from KD1JV. This was donated to the channel some time ago, actually. So we could use this. We could try that out. I'll have to find the instructions for it. Would you rather see me use this kit? Actually, I think I kind of like it because it's got the LEDs. Or would you rather try something new? For example, using a Raspberry, what is it called? It's the Raspberry Pi microcontroller, not the actual Raspberry Pi. I forget what it's called. But we could try something new. Or we could try an analog VFO, although I'm not sure I'm ready for that yet. So we've got some options here. What would you like? I'm actually kind of leaning toward this. What do you guys think? I think this is pretty rad with the old school LED. So, and this is a complete kit here. What do you think? Let me know in the comments. I mean, I really want to know. So let's talk about VFO options. I'm open to doing analog, although I don't have a frequency counter right now, or do I? I have that Nano VNA, so I can. And I have other receivers I can use to listen to it. Let me know what your thoughts are. I want something that's going to be easily repeatable, though. But the thing is that just about any VFO will work with this. It can be made to work, I should say. So yeah, let me know what you think. All right, guys. Well, thanks for watching. We'll see you next time. 73.